All right, welcome back, everyone. Our final section for this course, we're going to talk about the second part of polynomials. And in this section, we're basically just going to talk about how to use the leading term test to choose the appropriate graph of a polynomial. If you want to choose the correct graph of a polynomial, use the leading term test to first establish the end behavior. That'll give you an idea of what the picture should look like. And if that doesn't rule out all the answers, it may be necessary to use the zeros or their multiplicities to determine the appropriate graph. So in this case, we want to determine the appropriate graph of the polynomial. We have f of x is equal to x to the 6th minus x to the 4th. And now we know the leading term in this case is the term with the highest power of x. So in this case, it's 1x to the 6th. And so our leading coefficient is 1. The degree is 6. And so it's even. And if you go back and look at the last section, you'll recognize that if we have a leading coefficient greater than 0 and the degree is even, that our end behavior, though we don't know what happens in the middle, the end behavior should look something like that. As we go to the left or go to the right, the equation should be rising upwards. Well, from our 4 pictures, we don't even need to know anything else. Obviously, these 3 are incorrect. And it has to be A. A is the only one whose end behavior matches what we get from the leading term. So let's try this again. We just want to determine the appropriate graph. We've got f of x is equal to x squared times x plus 3 times x minus 2. Now, with a factored form like this, it's not as clear to what the leading term is. But we can figure it out relatively easily by just multiplying all of the first terms. So x squared times x times x. Well, that's just going to give us 1x to the 4th. And that's going to be our leading term. Right? No matter how we multiply it, every other term is going to have an x with an exponent less than 4. So this has to be our leading term. The leading coefficient is obviously greater than 1. The degree is still even. And so just like the last one, we're going to get the same type of end behavior. Unfortunately, that only eliminates one of the possible answers. But there's more information that we can get from this function, namely what the zeros are. And so we know the zeros in this case. We're going to get x equals 0 with a multiplicity of 2. And you're going to get x equals negative 3 and x equals positive 2, both with a multiplicity of 1. So if you go back to the last section and you read a little bit about multiplicity, or in the last video, the multiplicity tells you that if the multiplicity is even, it'll touch the axis at that point and bounce off. And if the multiplicity is odd, then it's going to cross the axis at that point. So, first let's see if we can match up the zeros to these graphs. Each should have a 0 at positive 2, negative 3, and 0. Well, they all cross at 0, so that's okay. This one, C, here, does not have a 0 at positive 2, right? It doesn't have a 0 here at positive 2. So we can get rid of that one. D has a 0 at negative 2 and positive 3, so that's opposite what we're looking at, so we can get rid of that one. And the answer should be A. And you can see that it crosses the axis at x equals negative 3. It crosses the axis at x equals 2, and it touches the axis and bounces off at x equals 0. That matches exactly what we expect from the multiplicities and the end behavior and everything else. So use what you know about the leading term tests, zeros and multiplicities, to rule out each of the different graphs, and then only keep the one that matches all of the information. And so at the end of this lesson, you should be able to use the characteristics of polynomials to select the appropriate graph of a function.